In TrueGrid, we can build geometry, and there are simple examples of that in many of the lessons in this introductory course series. But there are other ways to bring geometry into TrueGrid. In our Projecting a Mesh Shell video, we read in element and coordinate files that contained polygonal data for a car model, but the element or connectivity and coordinate polygonal geometry system we use actually comes from the needs in the biomechanical engineering field. In medical imaging, the marching cubes algorithm is used to create 3D models of anatomical structures like bones, organs, or blood vessels from CT and MRI data. TrueGrid can import these geometry files using the VPSD or Viewpoint Surface Definition Files Import command. The file format is called STL for STereoLithography, or Standard Tessellation Language. It's commonly used in 3D printing. The STL format has been widely adopted and standardized. TrueGrid imports these files and treats them like any other surface. IGES files are the most commonly imported file into TrueGrid. The IGES format is an international standard used to transfer geometry models from one CAD system to another. There is no enforcement of the standard, so there is some disagreement in the interpretation of the standard. TrueGrid does a good job of handling the different variations. An untrimmed surface is tessellated with quadrilaterals. A trimmed surface can have a boundary including holes in the middle, and they are tessellated using quadrilaterals in the middle and triangles to the boundary. TrueGrid does not handle solid geometry, so be sure to select trimmed surfaces when porting a CAD model into TrueGrid. IGES command. This command reads the IGES file and then tessellates the surfaces and 3D curves unless the USEIGES command was issued before the IGES command was issued. Tessellation can take several minutes in a large model. When the IGES is first read, the surfaces must be tessellated. The data can then be saved in a file using the Save IGES command. In subsequent runs of the session file, the USEIGES command will take advantage of the tessellations stored from the previous run. The USEIGES command must come before the IGES command. TrueGrid is tolerant of small inaccuracies in surfaces. Because of the nature of the projection command, TrueGrid is not tolerant of intersecting surfaces that are tangent to each other. When surfaces are tangent to one another, you need to form a composite surface with all mutually tangent surfaces. This is ideal because it forces you to reduce the number of useful surfaces to a very small set of composite surfaces. This is the best way to organize the geometry. This is an example to show you how to use the Save IGES command so that you can avoid the time to retessellate an IGES file each time you reopen it. This is a big time saver. We are going to start TrueGrid without a command file and go straight into the merge phase by typing merge. We are going to import an IGES file. Now, it didn't take long to tessellate these surfaces, but if you have a model with tens of thousands of parts, it may take a few minutes, and it may look like there are only a few surfaces. There are more surfaces here. What you are seeing is that some CAD systems first require the operator to define the boundaries of the operating space for their model. Thus, the boundaries import as planes. We are going to remove these planes from the picture. Now, you may not even be able to see the geometry we're looking for, but it's this tiny little dot in the middle. If you hit Restore, it will recalculate the containing box. Now, it has rescaled everything based upon the new containing box. This is half of a car bumper, and there's a lot of tessellation going on. So I want to save it. I don't want to recalculate it every time I run this problem. Go to the CAD menu and select Save IGES. It's not actually going to save the IGES file. Instead, it's going to save the tessellated surfaces generated, not everything else. You have to give it a name. I'm going to call this bumper.bin, and bin here stands for binary. Now I have a file saved in my working directory named bumper.bin that contains the tessellated surfaces. This is a binary file, so you can't open it and edit it like you can a TG file or CAD files. When I want to take a break from working on this model, I close TrueGrid and I go to my tsave file. I open it up in my text editor. I'm just cleaning up the unnecessary comment lines in this file here so we can focus on the commands. All I'm left with are these 3 lines. As you can see, it saved the binary file name here. If I were to run this TG file again without changing it, it would re-tessellate the IGES files again and resave the binary file, so there would be no time-saving advantage. I don't need to run save again, so to disable this command, I add a C, and that turns this line into a comment. However, I want to use the file of tessellated data instead of reading in the original IGES file again. So I add the USEIGES command before the IGES command line. USEIGES followed by the file path and name. I will copy it from here and then just change the extension to .bin. I'm omitting the 11 and semicolon because an IGES file can be transformed, but a USEIGES file cannot, so there's no semicolon needed. Now I'm going to write this file. I will call it use.tg, but you can call yours whatever you like. Now let's run TrueGrid and open it with the use.tg file that we just created. If you had tens of thousands of parts in your IGES file, this method will have saved you a great deal of time to avoid the tessellation again. It's an important technique to utilize in larger models.